Okay, hi guys. So in this lecture, we'll be starting off with we'll be continuing the reaction of various different reagents of on acid groups and acid derivatives, and then we'll be seeing haloform reaction. Okay, so let's get started. So first we have RC double bond OH. Okay, in presence of NaHCO3, it will form, let's suppose, A gas. In presence of NaNH2, it will form B gas. In presence of NaH, again it forms C gas. In presence of uh, sodium metal will get D gas, and in presence of again CS3 MgBr Grignard reagent, we get product as E gas. Okay, so what are all the gases we have to identify? So A is obviously CO2. Okay, here again we'll have NH3 as the gas. In the C gas we'll have H2. D also would have H2, and E would have methane. Okay, so the next question is, which of the following does not react with the NaHCO3? Which of the following does not react with NaHCO3? We have options as first this one, B we have this one, C we have OH here and CH3 here, and D we have something like this. Okay, so obviously this will actually not react with NaHCO3 because it is less acidic than even alcohol, than phenol. Okay, and even this will not react with NaHCO3 as phenol itself is less acidic than H2CO3, and on the top of it we are also having a plus I effect attached on the phenol, and this will also not react with NaHCO3. Similarly, if we talk about this and this, if you just see that this is obviously our picric acid, so we have three minus M groups attached to the phenol, and to the extent that it becomes more acidic than H2CO3. Okay, hence this will not react. This will actually react, and this will also, on losing the oxygen atoms, it forms equivalent RS. If you can just see, so we'll have 4 equivalent RS in this case. Okay, hence it would be highly stable compound. Okay, so it will also react with NaHCO3. So now let's delve into another test for enol, and phenol is a enol. So we know that FeCl3 is a test for enol. Okay, and phenol is a enol. Okay, so what actually happens when we react PHOH with phenol, or rather FeCl3, I beg your pardon, we get a violet colored compound, something like this whole thrice. This is violet colored. Okay, and secondly, this will also undergo reaction with FeCl3 because it's enol, containing enol group. Okay, and if we react ROH with FeCl3, what will be the compound? No reaction. Why? It is not enol. Now let's actually move on to our second or important reaction, which is called haloform reaction. Okay, so it is very important. Okay, so many questions are asked in previous year papers of from this reaction itself. So, okay, so we have this group, okay, where Y can be either H, R, pH, okay, anything, and we have I2 and NaOH. You can also take NaOI in place of I2 plus NaOH. We get a yellow colored precipitate of CHI3, okay, and we get CHCO2 minus Na plus Y is also there, YCO2 minus Na plus. Okay, we'll see the mechanism in a short while, but let me take some more examples on the same. If we react it with Br2 and NaOH, we'll be getting something like CHBr3 plus YCO2 minus Na plus. Then if we react it with something like again YCO, C double bond of CH3 plus Cl2 in presence of, okay, so here we have to use KOH rather, not NaOH. We have to use KOH, and here also we'll be getting K plus, okay, Cl2 plus CaOH whole twice. So what will we be getting? We'll be getting something like again CHCl3 plus YCO2 calcium. Okay, so now let us see the mechanism of this reaction. Okay, so mechanism is something like, first we have this compound. What actually happens with this compound is we are placing it in NaOH. So what will happen? O will take away this acidic hydrogen. Okay, so we'll get something like this. This will react with I and will act as a nucleophile and will treat this as electrophile. Okay, and as a result we'll be getting something like, let me draw it there itself, we'll be getting something like this compound. Okay, now what will happen is, again this on reaction with OH minus, it will again on reaction with OH minus, it will attack on this carbon atom rather, it will attack on this carbon atom and will attack again, take one of the acidic hydrogens and will get again CH minus and I. This will again react with I2 and we'll be getting something like YC double bond O CHI2. Then again in basic medium we'll be having something like this C minus I2. Again on reaction with electrophile, which is I2 in this case, we'll be getting this compound. Okay, what next? Now what will happen is, we are again placing it in OH or basic medium. OH will actually attack this partially positively charged carbon atom, and as a result we'll be getting O minus and OH attached here. Okay, and Ci3 also. Ci3 will leave the compound as the oxygen atom, negatively charged oxygen atom, forms a double bond with the carbon atom. We'll get Ci3 minus in presence of water, or we are also having basic medium. What will happen is acetaldehyde will form and CH3 minus will attack on the water molecule to get something like a CHI3, which forms a yellow colored precipitate. Okay, this is the yellow PPT. Okay, so this completes the mechanism. Okay, so now we'll be seeing the characteristics of this reaction in the next lecture. Okay, and we'll be seeing some more reactions of compounds with NaOI or I2 plus NaOH. Till then, good luck and goodbye.